The pH scale. The pH scale is, if you look at that capital H there in pH, the pH scale is simply a way to measure the hydrogen ion concentration in a solution. Okay, if you look right here, this is the equation that they give you on the AP exam. You take the negative log of the hydrogen ion concentration, and it's going to give you a number that is typically a number between 0 and 14. Usually when the number is between 0 and 7, you consider that an acid. If it's between 7 and 14, you consider it a base. And if it's right at 7, you consider it neutral. Even though that's not a perfect definition, that's a good place to start. So when you know the hydrogen ion concentration, you simply use your calculator and you take the negative log of it. So let's say, for example, one of our earlier ones had, let's say it had a hydrogen ion concentration of 1.8 times 10 to the minus 6th. Okay, and that is the H plus concentration. Remember, H plus and H3O plus mean the same thing. So I literally would use my calculator. I would type negative log and then type 1.8 times 10 to the minus 6, hit equals, and you get an answer, a pH of around 5.74. So the closer you get to 7, the fewer the hydrogen ions are in the solution. The farther from 7 you get, closer to 0, the more hydrogen ions you have in that solution. So a pH of 1 versus a pH of 6 means that you have a lot more hydrogen ions at a pH of 1 in the solution than you do at a pH of 6. Okay? And another scale that we use that also you don't really hear about as much, but is basically the same scale, is what's called the pOH scale. And you do it the exact same way. You take the negative log of the hydroxide ion concentration and you plug that in. You take, again, you get the pOH. And of course, there is a relationship between those two that if you know one or the other, you add them up. The pH plus the pOH is always equal to the number 14. So when you know the pH, you can easily find the pOH by subtracting it from 14 and vice versa. Okay, and then using that same logic, getting rid of the logs, these are also given on the exam. You can see down here all the equations that are given on the exam. That the hydroxide ion concentration times the hydrogen ion concentration is 1 times 10 to the minus 14th. Okay, so what they don't give you on the AP exam is what if they give you the pH and they ask you to find the hydrogen ion? Or what if they give you the pOH and they ask you to find the hydroxide ion concentration? Okay, this is one where you do need to know what's the opposite of log. How do you get rid of a log? Is you take, these are log base 10, so you take 10 to the negative pH. So that's an important equation as well that, again, is not given on the AP test. They assume that you know that the inverse of log of a log base 10 is taking 10 to the negative of that pH. And that will get you the hydrogen ion concentration. You take 10 to the negative pOH, and you get the hydroxide ion concentration. So there's basically 4 different things here that we can move between. We can move between pH, pOH, the hydrogen ion concentration, and the hydroxide ion concentration. If they give you one of those 4 things, you should be able to convert to all of the other ones as well. Okay, now here's a nice little table to kind of help you with that. That will help you go between one or the other. Again, there's no cute little table like this given on the AP test. And it really doesn't matter where you start, and it doesn't matter which direction you go in. For example, they might give you the pH and ask you to find the hydroxide ion concentration. You can go this way to find it, or you can go this way to find it. Again, it doesn't matter. Okay? So going between one or the other is usually pretty straightforward. So let me do just a couple of example problems here for you, and that will be that. Then we'll finish up this video. So, number 1 says calculate the pH of a solution of 0.030 molar hydrochloric acid. The only reason we can do this is because hydrochloric acid is a strong acid. And like we said in the last video, if it's 0.030 molar HCl, notice that arrow, not an equilibrium arrow. Okay, remember that pH is a measure of the hydrogen ion concentration. So it's not a measure of the acid concentration, it's a measure of the hydrogen ion concentration. So this H plus that's over here, because it's a strong acid, is also 0.030. So how do you calculate that? You're going to say that the pH is equal to the negative log of 0.030. So negative log of 0.030 equals 1.5. Okay? And again, that doesn't really tell you if it's a strong acid or a weak acid, but a pH of 1.5, that just means you have a pretty high concentration of hydrogen ions in there. Okay? And again, a pH of 6 means you're starting to get down to a pretty low concentration of hydrogen ions. What does a pH of greater than 7 mean? We're going to get to that here in a little bit. For right now, let's just focus on the more common possibilities. Okay, number 2 says calculate the pH of a 0.010 solution of lithium hydroxide. Again, a strong base. So if it's 0.010 molar LiOH, that does completely dissociate into Li plus and OH minus, which means your hydroxide ion concentration is also going to be 0.010. Okay, what happens in a situation where it's not a strong, again, we'll get there. We're doing the easy ones for right now. So that means that the hydroxide ion concentration is 0.010. So basically we're right here, and we need to get up to, what are they asking us for? They're asking us for the pH. So we can go this way, we can get the POH, and then go to the pH from there, or we can go this way, get the hydrogen ion concentration, and then go to here. Okay, and it seems kind of weird. Wait a minute. If it only has hydroxide in it, how can it have some hydrogen ion in it as well? That's a great question. If it's a basic solution, how does it have hydrogen in it at all? We'll get there. Don't worry. Okay, but just know that to convert from one to the other, that's how you do it. So I'm gonna go this way just because we got to go one way, right? So 1 times 10 to the minus 14th over 0.010 is going to give me the hydrogen ion concentration. Okay, so 1 times 10 to the minus 14th divided by 0.01 equals 1 times 10 to the negative 12th. And then the pH is equal to the negative log of that number. So the negative log of that answer is exactly 12. So the pH equals 12 in that case. Okay? Now, if I had gone the other way, I could have taken the negative log. So negative log of 0.010 equals 2. So that gives me a POH of 2. And then 14 minus 2 equals 12 to get me, notice we get the exact same answer of 12 no matter which way we go. Okay, a couple more, then we'll be done. So calculate the hydrogen ion concentration in a solution with a pH of 10.432. So that means we're going to take 10 to the negative 4.32. So 10 to the power of negative 4.32 equals, I'm going to have my calculator put it into scientific notation for me because I'm lazy. 4.8 times 10 to the minus 5th would be the hydrogen ion concentration. And then our final one, calculate the pH of a solution made by dissolving 2 grams of potassium hydroxide in water for a total volume of 250 milliliters. Okay, this one's going to be a little bit interesting. But the first thing we want to do is we want to get the concentration of KOH. So we need to take 2.00 grams of KOH. And then I'm looking at my periodic table. Potassium is 39.1 plus 16 plus 1. Still in scientific notation. Don't need that in scientific notation. So there's 56.1 grams in 1 mole of KOH. So 2 divided by 56.1, don't really care what the answer is, because then I'm simply going to divide it by 0.250 liters, and I get a concentration of 0.143 molar KOH, which again, because it's a strong base, completely dissociates, and that means that the hydroxide ion concentration is also 0.143 molar. Okay, and now we're in the same situation we were back here at question number 2. So let's go the other way this time. So I'm going to take the negative log. The negative log of that answer gets me the POH, which is 0.845. And then I'm going to take 14 minus that answer. And I get a pH, a final pH of right around 13.15 as my final one. Now notice all of these examples that we've done so far have all dealt with strong acids or strong bases. Okay, in the next video, you can see it already. In the next video, we're going to talk about what happens when it's a weak acid or a weak base. How does that affect the pH? Again, remember that pH and POH are not a measure of the acid. They're a measure of the hydrogen ion or the hydroxide ion concentration. So anytime you use pH, you're not using this number, or you're not solving for this number. You're always solving for this number, the hydrogen or the hydroxide ion concentration.